friction, and what is the friction now basically? Yes, now here friction is one type of force which will opposes the relative motion between the two bodies. Basically, friction does not oppose the body motion. It will opposes the relative motion of the two bodies. Yes, it will tries to oppose the relative motion between the two bodies. Now here, let us say we have placed the two bodies, we have placed the one over other. When one body is moving, so the second body will tries to oppose. Now here these two bodies are there. Now these two bodies want to be always together. They want to move together. So it will oppose a relative motion between the two bodies. The force of friction opposes the relative motion of one body when other body is in motion. Right. And force of friction, how the force of friction will act, you tell me now. I have taken a body, let us say, I have taken two bodies, we have taken. So two bodies we have. Right. So we have taken two bodies we have taken now. So here let us say we have this is one body, this is the other body. These two are placed one over other. Now, when this body tries to move this direction, this M1 will try to stop that body. And so then this, if the M2 tries to move the right side, and there is some opposing force which will act in between the two contacts of the body. Here at this location, these two bodies are in contact now. Here we have the frictional force will act. So this is the frictional force. Friction force is always between the contact between the two bodies, right? So the frictional force, which will act always tangential force, that is a parallel to the contact surface, parallel to the contact surface, and opposes the relative motion. And if a force is applied to move the body is not moving. If the body is not moving, then how much the friction? Then we can call that friction is a static friction. If the body is at rest, then what type of friction it has? Static friction. If the body is in motion, that is called as a kinetic friction. If the body is in motion, that is called as a kinetic friction. If the body is rolling like a wheels, then that is called as a rolling friction. Then we'll call that as a rolling friction. So we have the three types of frictions we are going to study. One is the static friction, kinetic friction, rolling friction. Static friction means what? When it is at rest. The kinetic friction is also a static friction, and kinetic friction is also called as a dynamic friction. When the body is in motion, then we have a kinetic friction. And if the body is rotating bodies, like a wheels type of bodies, will have friction is a rolling friction. Now, static friction. So here static friction is what, tell me now? Friction present between the two surfaces in contact when body is at rest are just tends to move, just going to move. That is called a static friction. And another very important thing, static friction is a self-adjusting force. And you will get to know this thing, this point is a very important point. And maximum value of static friction is called as a limiting friction. Maximum value of static friction is called as a limiting friction. So the limiting friction formula limiting friction formula, which is equal to mu s into n. Limiting friction is what will be mu s into n. N is a normal reaction and mu s is called as a coefficient of static friction. Mu s is called as the coefficient of static friction. Mu s is the coefficient of static friction and n is a normal reaction. And kinetic friction that is given will denote as Fk, and which will be equal to mu k into n, where mu k is called as the coefficient of kinetic friction. Coefficient of kinetic friction. And this is a rolling friction. So that is Fr, which will be given as mu r into n. Mu r into n. Mu r is a coefficient of rolling friction. And do remember, there is no formula for static friction, where this is what tell me now, this is a formula for what? Limiting friction ka formula. Limiting friction formula. So in these relations, if you see now, here mu s is greater than mu k is greater than mu r. And similarly, we can say now here limiting friction greater than kinetic friction greater than rolling friction. Okay. And mu s is called as what will be a coefficient of static friction, which will be given as what will be now here Fl by N. And mu k, so that is given as what will be now Fk by N. N is a normal reaction. And this mu r, which is equal to Fr by N. Right. This is called it as what element of coefficient of static friction. And this mu k, which is called as the coefficient of kinetic friction. This is called as a coefficient of rolling friction. And which friction is more? And rolling friction is less. Then Okay. See the graph between the frictional force and the pulling force. So here you might be recollected now here. So we have a body, if we observe carefully, when we applied some force now here, when we apply some force now here, 1 Newton, 2 Newtons to slowly increasing the force now here. So let us say here, this object can able to move for a force of 8 Newtons. We are applying the force of 1 Newtons. Then will the object will move? No. Then how much the frictional force? Now the frictional force is how much now? So look at now. Here this object can move for how much force? 8 Newtons. You apply the force of 1 Newton you applied. Then how much the frictional force? 1 Newton. Okay. So that means what is the thing here? Basically now friction is what I mean now? Opposing force. So here look at now. You applied the body. What we can consider now, we applied some force of 1 Newton is applied, but still this object is not moving. Why it is not moving here? That is because now there is some opposition is there, isn't it? Now this opposition is this direction now. We apply the 1 Newton force is applied, but still this body is not moving. Then means what we can consider now, the applied force and frictional force is balanced. Okay. Then how much the frictional force now? That's why the body is not moving. Understood what I'm saying here? So now you tell me we apply the 2 Newtons force is applied. How much the frictional force? 2 Newtons. Understood what I'm saying? Why? Because and that one we should call self-adjusting force. And if you apply 3 Newtons, how much the frictional force? 3 Newtons. 5 Newtons we applied. 5 Newtons. 7 Newtons. 7. If we apply 8 Newtons, 8 Newtons only. When we start apply the 8.001, let us say, then what happens? You tell me now here. The body start moving now. In that case, if you observe carefully, when the body is at rest, to make the body in motion, we require the 8 newtons of force. More than 8 newtons are required. But once the body started the motion, for that to continue the motion, we require the less force. Understand what I'm saying here? If the body is completely at rest, now to initiate the motion of a body, we require the more force is required. Once the body started the motion, the required force is less compared to initial force. Isn't it? Why? Because as once the body started the motion, you might be observed. Let us say the car is stopped. When you are pushing the car, once the car first to start the motion, so we require the more force we need to apply. Once the car started the motion, a less force is sufficient to move, isn't it? That's why the graph you see this thing here. Look at now. Here we apply the force. Yes, when you apply the force is zero, frictional force is zero. When you apply the 1 Newton force we applied, and frictional force is 1 Newton, and 2 Newtons we applied, frictional force is 2 Newtons. 10 Newtons we applied, that is frictional force is 10 Newtons. Now let us say the body started the motion. But to start the motion, we need this much of force is required. Once the body started the motion, less force is sufficient to continue the motion. And once the body started the motion, then what type of friction it is now? That is now no static, that is a kinetic friction. Once the body started the motion, that is no more static, the body is in a motion now. Then that is what type of friction it will contain? Kinetic friction will contain. And kinetic friction fixed value, remember, kinetic friction is a fixed quantity. Yes, that's why it is a constant always. Up to here, this is what type of friction? Up to here, this is what type of friction is static friction. So here up to here, thereafter the body motion started now. Then this is what tell me now kinetic friction. This is okay. Take this diagram. Okay. Next, laws of friction. Laws of friction. Yes. So what the laws of friction is saying? Friction is a constant force which opposes the relative motion between the bodies in contact, which opposes the relative motion between the two bodies. And static friction and kinetic frictions are independent of area of contact. These are independent of area of contact, whereas rolling friction depends on area of contact. Area of contact means this body is in contact with this much of area. Static friction and kinetic friction does not depend upon area of contact, but rolling friction depends upon area of contact. And friction depends upon the surfaces in contact. Will depends upon the surfaces in contact. So that means now we have taken a two ball surface we have taken now. If the two surfaces are very smooth, highly smooth, then the friction is zero. And if there are the two surfaces rough surfaces and friction non-zero. It depends upon the contact, and friction depends upon the impurities addition as well as the temperature also depends. And friction is directly proportional to normal reaction. So the frictional force F, which we used to call it as directly proportional to N. Now that frictional force, which will be given as what we can say, we have a proportionality constant, that is mu into N, where mu is called it as a coefficient of friction. Coefficient of friction. So it is static friction mu s, kinetic friction mu k, rolling friction mu r will write. Right. So this is the frictional loss. Angle of friction. Angle of friction. And let us consider we have the body. Right. So this body of mass is m. Let us say that this body and which is moving this direction. The body which is moving like this. Now you can see now here first. Now this weight of a body is vertically downward direction, mg. And the normal reaction, yes, upward direction. This is the normal reaction n. And so body moving right side, which direction we have frictional force now? And frictional force is lies here now. This is the frictional force here. Now, so here we have two forces now. One is normal reaction, the other one is frictional force. The resultant of these two, where it will lies. Resultant of these two will lies somewhere here now. The resultant of these two lies here. And this is a resultant force. Okay, we are calling this as, let us say, Fc. So that means how much is Fc equal to resultant of the normal reaction and the frictional force. These two angle 90 degrees now. So that should be given as what? Tell me now. This is F square plus what? Tell me now. N square. Now there is some angle made by the resultant force with the normal reaction. So this angle we are calling it as a theta. This angle is called as the angle of friction. The angle between the resultant of normal reaction and frictional force with the normal reaction is called it as the angle of friction. So how much this angle you can see now? This is tan theta. This is tan theta, which is equal to what? Tell me now. F by N. Tan theta equal to what? Tell me now. This is F na. So that is opposite by adjacent. F by N. So as we know, this is tan theta, where F is equal to what? Tell me now. Mu N by N. So this will come to be what? Tell me now. Tan theta, which will be equal to mu. Tan theta equal to mu, where theta is called as the angle of friction and mu is called as the coefficient of friction. So if they given this as the coefficient of friction, angle of friction is given, we can get the coefficient of friction mu, which is equal to what? You tell me now here, tan theta. Mu equal to tan theta. Mu is the coefficient of friction. Theta is called as the angle of friction.